Welcome to this training on laser physics. Before we talk about treatment, settings, safety, or results, we must first understand the science behind the laser. A laser is not magic. A laser is not just a machine with buttons. A laser is controlled energy. And when that energy touches tissue, it follows the laws of physics. In this section, we will break down how laser light is created, how it travels, how it is delivered, and why it interacts differently with skin, pigment, blood, water, and other targets. The goal is not to make laser physics complicated. The goal is to make it simple, practical, and useful. Because once you understand the physics, you stop guessing. You begin to think, adjust, and treat with intelligence. Master the science, and you will understand the treatment.
Copyright notice.
2026 Amaury J. Agoncillo. All rights reserved. No part of this content may be copied, reproduced, republished, uploaded, posted, transmitted, distributed, modified, or used in any form without prior written consent from the copyright owner, except for brief quotations used for educational or review purposes with proper attribution. Unauthorized use, duplication, or distribution of this material, whether for commercial or non-commercial purposes, may result in legal action.
Properties of laser beam. Now that we understand how laser light is created, let's talk about what makes the laser beam different from regular light. Laser light has special properties that allow it to be focused, controlled, and used for precise treatment. 1. Monochromatic light. Monochromatic means one color or one wavelength. Regular light contains many colors and many wavelengths. A laser is different because it produces a very specific wavelength. For example, a CO2 laser produces 10,600 nanometers. An ND-YAG laser produces 1,064 nanometers. An Alexandrite laser produces 755 nanometers. This matters because different wavelengths target different chromophores in the skin, such as water, melanin, hemoglobin, or tattoo pigment. Monochromatic property means the laser uses one main wavelength, and that wavelength determines what target the laser energy will affect. 2. Coherent property means the light waves are organized and moving together. Think of it like soldiers marching in the same rhythm. The photons are traveling in step instead of randomly spreading everywhere like a flashlight. This makes laser light more controlled and more powerful than ordinary light. Coherence means the laser light is organized. The waves move together, making the beam more controlled and effective. 3. Collimated. This means the beam stays narrow and does not spread out quickly. A flashlight spreads light in many directions. A laser beam can travel in a straighter, tighter path. This is one reason lasers can deliver energy with precision. A collimated laser beam stays focused and travels in a straight direction with minimal spreading and energy loss. Laser beam properties are important because they explain why laser light is so different from regular light. A laser beam is specific, organized, focused, and controllable. When you understand these properties, you begin to understand why laser treatments are not just about pressing buttons. They are about controlling energy with knowledge. Let us get to know what makes up a laser. Energy source/pump source, this is what powers the laser. It gives energy to the laser material so it can start producing light. Active medium, this is the material inside the laser that creates the wavelength. Different materials create different types of laser light. Optical cavity, also known as the resonator. This is the chamber where the light bounces back and forth. As it bounces, the light becomes stronger. High reflective mirror. This mirror keeps most of the light inside the laser cavity so it can continue to build energy. Output coupler mirror, this mirror lets some of the light escape. That escaping light becomes the laser beam. Delivery system, this carries the laser beam from the machine to the treatment area. It can be a fiber, arm, handpiece, scanner, or lens. Think of it this way. The energy source wakes up the laser material, the cavity strengthens the light, the mirrors control it, and the delivery system brings that laser energy to the tissue. Laser wavelengths can operate from ultraviolet through visible light and into infrared The only part we can see is the visible range, from about 400 to 700 nanometers. Ultraviolet is below 400 nanometers, and infrared is above 700 nanometers. Both are invisible to the human eye, but they can still interact strongly with tissue. This is why laser safety is important, even when you cannot see the beam. Visible does not mean safe. Invisible does not mean harmless. Laser energy is not always delivered the same way. How the laser releases energy is called the pulse type. There are three basic pulse types you should understand: continuous wave, single pulse, and multi-pulse. Continuous wave, or CW, means the laser stays on continuously as long as the foot pedal or trigger is activated. The energy flows without stopping. Think of CW like turning on a faucet and letting water flow continuously. Because heat keeps building, CW can create faster thermal buildup if movement, timing, and cooling are not controlled. Single pulse means the laser fires one controlled burst of energy at a time. One trigger equals one pulse. This gives the operator more control over placement, overlap, and tissue response. It is useful when precision matters and when you want to observe the skin reaction between pulses. Multi-pulse means the laser delivers several pulses in a sequence. Instead of one burst, the energy is divided into multiple smaller deliveries. This can help control how heat is delivered into the tissue. The pauses between pulses may allow partial cooling, depending on the pulse timing, energy, and tissue target. Here's the simple way to remember it. CW keeps flowing. Single pulse fires once. Multi-pulse fires in a control series. In laser treatments, pulse type affects how heat builds, how tissue reacts, and how safely energy is delivered. That is why understanding pulse type is part of mastering laser physics. Do not just fire the laser, understand how the energy is being delivered. That is how you protect the skin, control the treatment, and improve your results. The skin has three main layers: the epidermis, the dermis, and the subcutaneous layer. The epidermis is the top layer and contains melanin, which gives skin its color. This is the layer we must protect, especially in darker skin types, because melanin can absorb laser energy and overheat. The dermis is deeper. This is where collagen, blood vessels, and hair follicles are found. Many laser treatments work by reaching this layer to stimulate collagen, reduce vessels, or affect hair follicles. The subcutaneous layer is the fatty layer below the dermis. Most aesthetic lasers do not directly target this layer, but some energy-based devices may affect deeper tissue. Now let's connect this to laser parameters. Wavelength chooses the target. Some wavelengths target melanin, some target hemoglobin, and some target water. Where that target is located determines which skin layer reacts. Spot size affects depth. A larger spot size can reach deeper into the skin, while a smaller spot size is usually more concentrated and superficial. Pulse width controls how fast heat is delivered. A short pulse width delivers heat quickly, which can create a stronger reaction, but can also increase the risk of burns or pigmentation issues if the epidermis overheats. A longer pulse width delivers heat more slowly, which can sometimes be safer for deeper or larger targets. Energy controls how much heat is delivered, and cooling protects the epidermis from overheating. So remember this simple rule: wavelength chooses the target, spot size influences depth, pulse width controls the speed of heat delivery, energy controls the amount of heat, and cooling protects the skin. When you understand the skin layers, you stop guessing and start treating with science. Lasers are not magic. Lasers follow physics. To understand laser treatments, you must understand the 6 key parameters: wavelength, energy, spot size, pulse width, frequency, and cooling. Wavelength chooses the target, such as melanin, hemoglobin, water, or tattoo pigment. Energy creates the effect by controlling how much heat is delivered. Spot size controls depth and energy distribution. Larger spots usually penetrate deeper, while smaller spots are more superficial and concentrated. Pulse width controls how fast heat is delivered. Short pulse widths deliver heat quickly, while longer pulse widths deliver heat more slowly. Frequency controls how often the laser fires. Higher frequency can increase treatment speed, but it can also stack heat if the tissue does not have time to cool. Cooling protects the skin surface. It reduces pain, protects the epidermis, and helps lower the risk of burns and pigmentation changes. Remember this: wavelength chooses the target, energy creates the effect, spot size controls depth, pulse width controls speed, frequency controls rhythm, and cooling protects the skin. Master the parameters, master the treatment. Thank you for watching. I truly appreciate your time and support. My goal is to make laser education easier to understand, safer to apply, and more useful for real treatments. If this video helped you, please like, share, and follow for more laser physics safety and treatment education. Remember, master the science, protect the patient, and treat with confidence.